Okay, so right now we're going to be talking about section 4.2. And in section 4.2, we're going to be looking at sigma notation. And so I'm going to go ahead and start with a couple problems off of page 267, and we're going to talk about those. So the very first problem that we're going to look at is problem number 2. So I'm going to write it down. And it has our sigma notation. That's what the big E is. It has a 6 on the top. And then it tells you what K is. Now, what it's telling you to do is you're going to start with 3, plugging it in for K. And then you're going to keep adding these together because this sigma notation means you're going to do the sum. So, I'm going to plug in 3 for K. Then I'm going to keep plugging in numbers after 3 until I get to 6. So I'm counting up to 6 because that number at the top, that tells me where I stop. So I'm now plugging in 4. Then I'm going to plug in 5. And then I'm going to plug in 6. Now, once I have these numbers plugged in, I'm going to go ahead and find the answer for each of those. And that will finish out my problem. So right this moment, this is 3 times 1 plus 4 times 2 plus 5 times 3 plus 6 times 4. So I'm really adding together 3 plus 8 plus 15 plus 24. And if you go ahead and add that up in your calculator, that should equal 50. All it wants you to do, it says find the sum. That's finding the sum. This is the number you start with. This is the number you end with. All right, now I'm going to do one more, and then I'm going to discuss a problem like number 5, and then we're going to keep on going. All right, so I've done number 2. Let's go ahead and go to number 4. Number 4 says that you have the sigma notation, so that means I'm going to find the sum, where j equals 3, so that's where you're going to start. And then it's going up to 5. And this is the formula that you have. You have 1 over j. So I'm going to go ahead and start plugging in. 1 over 3 plus, because I plugged in 3, now I have to keep going all the way up to 5. 1 over 4, 1 over 5. Now, you want to add those together. You can do that by getting a common denominator. Now, I know that 5 and 4 go into 20, but 3 won't go into 20, so I have to think of something bigger. So that's going to actually be 60 because 3 will go into 60, so I'm going to have to use 60 as my common denominator. You've got a calculator, it'll add it up, but I'm going to just go ahead and get a common denominator of 60. So 3 times what makes 60? Well, let's say it's going to be 20, so 20 times 1 is 20. 4 times what makes 60? Well, that'll be 15, so 15 times 1 is 15. 5 times what is 60? I think that's 12, so 12 times 1 is 12. If you add it up, you're going to get 47 over 60. And that's your sum. And that's what it wanted you to do. Now, I'm going to do one like number 5 because number 5 is a little bit different. Okay, so let's go ahead and look at this. This will be an example like 5. All right, now number 5 is not hard, but it just doesn't have something that you can plug something into. So I'm going to go ahead and say mine is k equals 1. But I'm going to go ahead and say that mine goes to 6. Well, the only thing that you have here on this problem when you look at number 5 is a C. You don't have anything to put your 1 into. So it's a constant term. And so that constant term would be like a 5 or a 7 or whatever. So you're going to go from 1 to 6. So that means that you're going to have it there 6 times. So 1, 2, 3, 4, 5, 6. So that's going to be 6C. There's nothing else you can do because you're adding up the constant terms 6 times because you're counting from 1 to 6. That's the first one, second one, third one, fourth one, fifth one, sixth one. So that's what you're going to have. So that's how to do the first part. Now, when you go to 7 through 14, all it wants you to do is write it in, use sigma notation to write the sum. So that'll be the next thing. Okay, they give you a problem. So when you look at the problem, like if we start with number 8, if I write down what it has, and they've already got it that we're going to be adding it up, so I'm just copying down our problem. Okay, all they want us to do is write what this is in sigma notation. That's it. All right, so the first thing you need to notice is the only thing that's changed in the problem. I'm going to underline it. That number, that number, that number, that number. That's the number that's changing. Everything else is the same. So when I write my sigma notation, okay, I'm going to have to start with 1 because it's the first number that was plugged in. You can call it whatever you want to. I'm going to call it K. Now, you can tell that it ends at 15, so that's how far it's going to go. Now, my function is going to look like this because the 5 and the 1 stay the same, but I'm going to have plus, and I've got to put the K here because, since I decided to use K is the one that we're plugging the numbers into. So all it asks you to do, it didn't say find the sum, it just said write the notation. So for number 8, that's all you would write. Now, I'm going to go on to another one that's a little more difficult, but you're looking for what is different. Okay, so we're done with that one. Okay, I'm going to pause it for just a second so I can write down the next problem, and then we'll go ahead and go to the next one. Okay, so I've written down problem number 12 for us to look at. Now, number 12 is a little different. If you notice, we have several things going on. Okay, now I know I'm going to have to do my sigma notation, so I'm going to get it ready. All right. The first thing that I notice is everything looks the same except what I'm circling. Now, the only thing that I see is different is this 2 that doesn't have anything beside it, and then all of a sudden we got 2n, and we don't know what n is. So, at this particular time, you can use whatever letter you want to. I'm going to start with K. But it's 2 and then there's nothing beside it. Well, that nothing beside it is probably a 1. That's the only way you would get 2 because the 2 is still here when I come over here. Now, the n, we don't know what that is, so that's the number that's being plugged in. So I'm going to put it up here on the top. Now, the next thing that I want you to notice is this right here is being multiplied by this big bracket every time. So if it's been multiplied by this bracket, then if I want to, I can just put 2 over n and factor it out and put it in the front. And then the bracket that I have, the only thing I've got to do is rewrite it. And I need to put where we have the 2 and then the n appears, I'm going to have to put 2k because k is what we're going to be plugging in. Now, at this point, I don't know what k is, and you don't have to know. You're just looking for what's different. So this would be the answer to number 12. You're just writing the sigma notation. Now, we're going to do one more, so I'm going to switch pages. Okay, I've written another problem up here. This one is problem number 14. Okay, on problem number 14, if you really look at it, we're going to start with our sigma notation again. So I'm going to go ahead and write that down. Now, I start looking to see the differences. And I notice that right here, That says 0. And this says n minus 1. There's my hint. That's what's changed. So that means I must start at 0 because that's what they plugged in. So I'm going to call that k. And then we're going all the way up to n minus 1. Now, the next thing I look at is there something in common that they multiply by this every single time? Well, yep, here it is. I'm underlining it twice. There it is. Remember I told you could factor it out, so let's put it on the outside. So I got it on the outside. Now all I'm going to do is rewrite the inside with a k in the spot where I circled. So that's going to be k over n. And that's going to be the answer. Looks kind of weird, but that's all we have to do on those problems.